So Patrick just told me a little bit about you, and I'm going to present myself. I'm Anna-Karin Bonamy. I'm a pediatrician and also working as a researcher in clinical epidemiology at the Karolinska Institute in Stockholm, Sweden. And I would like to thank the epidemiology section of the ESPR who invited me here today, and especially Patrick and Luigi, who introduced the subject of meta-analysis this morning. And you know, Luigi, I've already interviewed the students of this morning, so they told me what you've been talking about, so now I know a bit what you learned this morning. The subject is meta-analysis of observational studies, and I'll talk quite specifically about that subject, but also a little bit about meta-analysis in general, so you don't get completely lost. And as you already know, meta-analysis is statistical analysis of a collection of analytic results for the purpose of integrating the findings. And that's a really general definition of meta-analysis. And the outline of my talk would be that I will first introduce a little bit why should we do and could we do meta-analysis of observational studies. I'll talk a lot about quality assessment and reporting, and I'll do that for two reasons. The first reason is that that's what you need to know both if you're going to do a meta-analysis and if you're going to review a meta-analysis. But also as a simple reader of meta-analysis, if you can't judge if the quality of that meta-analysis is good, it's no use reading it actually. Then we're going to do a journal club, and if we have some time left at the end, we're going to talk about the Simpson paradox. If we don't have time left at the end, I suggest that you Google or do anything to read about the Simpson paradox, because that's important to know what that is, and it's quite easy to grasp that subject by yourself, I think. We have to think about what kind of studies can actually be included in a meta-analysis. And I would say, in a very broad general definition, that depends on the question that you are asking, your research question. What would you like to know? Because I would say that more or less any quantitative study could be included in a meta-analysis if you're really giving some thought to what would you like to know, is this study answering the question, and can this study or the studies included in that meta-analysis yield an unbiased estimate of the effect size that I am looking for. And this is a more philosophical kind of mindset. It's not so cookbookish, but I think you might understand what I'm meaning. And I've defined meta-analysis and a little bit about them, but what is an observational study? Because that's the other part of my subject. I'm going to talk about meta-analysis of observational studies. And it might seem, I think it's obvious to most of you what an observational study is, but just so it's clear to everyone, an observational study is a study where we make inference about the effect of an exposure that cannot be randomly assigned by the researcher. And I'll give some more practical examples, but that is the very broad definition of an observational study. To me at least. You might, we are not so many here, so if you have objections, questions, if it's incomprehensible what I'm saying, just raise your hand and tell me. Because we are 10 people in the room, so it shouldn't be so formal. And why I started to talk about that there are reasons for which we are making meta-analysis of observational studies, and I'll just give you a few of those reasons. If you're looking for rare events, it's not very practical to randomly assign people in a randomized controlled trial, to randomize thousands of people that you have to follow up closely and do lots of analysis that are expensive, to find only a few events that you're interested in. Then it's much more practical to take a large cohort of people and make an observational study where you can show an effect, and then you can take several observational studies of that kind and pool them into a meta-analysis. If you're looking for exposures that have outcomes that takes long time to occur. If you want to know if being born preterm is really a risk factor for high blood pressure in adolescence, you have two reasons to do an observational study. One is that you cannot randomly assign preterm birth. Of course you can, but it would never be considered ethical to deliver women preterm just to do a study. So you cannot randomly assign preterm birth, and you would have to wait for 20 years before measuring the blood pressure in adolescence or young adulthood. And then there is a rationale for making an observational study in a cohort of preterm-born subjects, and to further on make meta-analysis of this kind of studies. If you're studying adverse effects after discontinuation of treatment, perhaps adverse effects of a treatment that you received only during a short time, and where you have adverse effects, perhaps cancers, much later in time, that's another reason to make an observational study and later on to make a meta-analysis of these studies. Another advantage of observational studies may be that often reporting of what is happening, the outcome, for example, is independent of what the patient is expecting. If you're doing a randomized controlled trial and you randomize placebo or a drug, the patient may expect to have certain outcomes that you are registering or certain adverse effects, which is often not the case if you're making a cohort study of people taking that drug for disease. And as I said earlier, one of the most important rationales to do observational studies and meta-analysis of observational studies is that there are lots of exposures that we cannot randomly assign. For example, prematurity, parental smoking, etc., etc. I guess you can give numbers of things that we cannot randomly assign. Do you have any questions so far? Is it clear? Great, we'll go on. And now to the main thing, I think, with meta-analysis of observational studies. And that is, as I introduced to you earlier, the quality assessment. Because you can do really lousy studies of a really lousy meta-analysis of observational studies if you don't know what studies you're supposed to include in your analysis. It's quite old by now, so it feels, it was published in 2000 by Stroop et al. For the Moose statement group, and the Moose is meta-analysis of observational studies in epidemiology. And I'm just distributing the paper back there later on, so you don't have to take notes, because the checklist that we are going through in detail is found in that paper. And you can see how to do them, how to present them, or how to read them. I always tell my PhD students to take, when they are reading an article critically for a journal club, for example, that they should always look for the checklist of the appropriate statement for all kinds of studies, because that really helps, I would say. And that's, I said, and that's the checklist, Moose. And the first part of the checklist is really, I would say, classic. It's common to all research. In the background, when you do meta-analysis of observational studies, you should define your problem, you should have an hypothesis, you should state what outcomes you're studying, what exposure you're studying, what study designs that you've included, and what populations. Sounds familiar, right? Yeah, that's what I thought as well, nothing new. Then we really come to this, that is what is specific to the meta-analysis in general, I would say, not only for observational studies. Somewhere in the paper, you should be able to find the qualifications of the people that did the literature search. Were they researchers? Was it your daughter or son who's only going to high school? Perhaps not a very good idea, but I'm sure it happens sometimes. Was it a librarian, which might be very familiar with literature search, but may not be as suited as you are to judge if a study is interesting or not for your purpose. So I would say ideally combine librarians that are really skilled in different databases with researchers that have skills, preferably clinical skills if you're studying a clinical question, in that area. That would yield the best search result. You should also in your article write or read what databases were searched, because that's also important. You might be able to find studies that are not indexed in Medline, but that may be really relevant and interesting to your question. So I just gave a few examples. There are, of course, lots of databases. If you're doing psychological studies, there are others, psychiatric. I'm sure there are pharmacological databases that I'm not even aware of. And you should really make an effort to include all available studies, and that should be mentioned in the article. How did they do an effort to include all the available studies? Were they using hand searching? I think that's really something that I'm using a lot. I've never done a meta-analysis, yet I'm here talking about it. But I've done systematic reviews, and I do a lot of hand searching actually in reference lists. I find a set of publications that I'd like to include, and then I really thoroughly go through their reference lists. And often I find several articles that I'm not finding in my search. You should make thorough lists of citations that you find and those that you exclude and why you excluded them from your meta-analysis. Because perhaps they were not at all studying the population you were interested in or studying another exposure or another outcome, or you can find other reasons certainly. And you should also look for what are they saying or what are you writing about studies in other languages. I myself, I speak Swedish, English, and French well enough to include studies in a systematic review from those languages. But I mean, most people perhaps don't, and then you should state that you only perhaps looked for English studies, because that's also the explanation why you might find another result than they perhaps have done in France doing the same kind of meta-analysis. And you should also describe if you've had any contact with authors. Have any one of you already been contacted by a researcher doing meta-analysis that asked for data? Yes? And what did you do? Did you give the data?
We have sent the data.
You sent the data as requested? Yes. Yeah. Was it to the hypertension review, preterm birth hypertension?
It was not this cohort. It was another in our group.
Okay. Okay, and so you sent the data?
Yes.
Yeah, and did they use it in a good way in that meta-analysis?
Did they use it
in a good way? Did it result in a... Yeah, it was good, great. So, and that should be described in the methods and search strategy if you've had contacts with authors, because then you might get results or have data that cannot be found by anyone else trying to do the same thing as you did. You should also, when you're reporting your methods, describe the relevance of the studies that you include for assessing the hypothesis to be tested, and that's perhaps obvious. You should describe how you select, what data you select from the studies, and how you code it if you recode it. And we'll talk a lot about how you're going to assess confounding in the studies included. You should make an assessment of heterogeneity. I'll talk a little bit about that later. I don't know, Luigi, did you talk a lot about heterogeneity this morning?
A little bit, yes.
Sorry?
Not a lot, a little bit.
A little bit about heterogeneity. I'm also going to talk a little bit about heterogeneity, and I'm going to warn a little bit for tests of heterogeneity. And now we are going to talk about how to assess the study quality in the studies included in a meta-analysis of observational studies. And I would have liked to have a picture here, but I didn't manage to get one this morning, from Newcastle and from Ottawa to make you remember this name, which is also really difficult to remember, I think, the Newcastle-Ottawa Scale for assessing the quality of non-randomized studies in meta-analysis. And once again, if you'd like to take notes, do that. But I put that assessment paper back there, or if you've taken it already, so you can see what things that you should assess when you include a study in a meta-analysis. And why Newcastle-Ottawa Scale? It's an instrument that is widely used, I would say, in most meta-analysis of observational studies today to assess the quality and to incorporate those quality assessments when you interpret the meta-analytic results. And that may seem abstract to you, but I'll explain it to you later. And what you're actually doing is that you give stars to each paper, each single paper that you would like to include in a meta-analysis, where you, as a reader, judge that study on 3 parameters: the selection of the study groups, the comparability of the study groups, and how they ascertained the outcome of interest. If it's a case-control study, it's the exposure of interest. But now we're talking about cohort studies. And what you can get is that you can get a maximum of 4 stars for selection, 2 stars for comparability, and 3 stars for outcome. And that adds up to a total of 9 stars. So remember that, 9 stars, because you'll read about how many stars the studies in the journal club got later on. If we start with the first parameter, which is selection, you're going to judge the representativeness of the exposed cohort. And I'll give an example. After each slide that is coming now, I'll give a short example, so you just integrate this into your minds, perhaps. And you're going to judge if the exposed cohort is truly representative of the average exposed cohort in the community, or did you select a part of that exposed cohort that has other attributes than the people in general, because that will severely affect the generalizability of your findings. It is okay, you still have the same star quality if it's only somewhat representative of the average whatever cohort in the community. But if you select a group, for example, nurses or volunteers or sometimes hospital-based cohorts, it may not be truly representative of the average cohort in the community. And if you don't describe your cohort at all, then you don't, of course, get a star. So, I'm giving an example. If you're going to assess health in adolescents after preterm birth, which is something that is done often in studies, you have to think about where do you choose your cohort. Because if you're working in a clinic and you are kind of recruiting patients among preterm-born subjects that is attending your clinic, you have to ask yourself, why are they attending your clinic? They might not be healthy. And that might not be the best way to select a cohort if you want to study effects in general after preterm birth. That's just a very simple example of selection. And so that was the exposed cohort. When you're going to select your non-exposed cohort, those who were not preterm born in this example, you have to think, are they really drawn from the same community as the exposed cohort? Or are they from a different source or setting? Or isn't it described at all? And as you understand, this does not only apply to meta-analysis of observational studies. Actually, it applies to all quality assessment of all observational studies that you may read or do yourself. And this is I think it's a very common error, is that you don't think about if the people that are exposed are really coming from the same cohort as the non-exposed persons. And if we go back to our example of health in adolescents after preterm birth, your non-exposed cohort, those that are term-born, cannot be a birth cohort from a delivery unit at the referral center for pregnancy complications, for example, which might happen. If I was going to do this kind of study at Karolinska, I might, if I was doing this really badly, take my preterm-born subjects from my outpatient clinic at Karolinska and take the term-born subjects from the delivery ward at the same month at Karolinska. But Karolinska is a tertiary referral center for pregnancy complications, which means that I would, among my term-born infants, select persons that are not truly representative of term-borns in the society in general. Are you following? Yes. This is basic, but yet you see it. You see errors all the time when you're reading the literature, actually. And then you have to ascertain your exposure. And if you find medical records where it has been preferably objectively assessed, you have kind of measured something. That's very good. But you could also use a structured interview to assess exposure. But there you have to be cautious if the interview is taking place before or after the outcome took place. If you're going to assess the risk of preterm birth in smoking mothers, you have to assess the smoking status of the mother before the baby is born preterm, preferably, because otherwise you may be dealing with recall bias, as we call it. Written self-reports or no description at all how you ascertain the exposures are not good. And if we take our example, so if you're studying preterm birth, pregnancy length is really what is important. And preferably, you should assess pregnancy length by ultrasound dating of pregnancy that is recorded in medical records. Last menstrual period may do if you don't have ultrasound dating, but that's really the gold standard. And then you have to demonstrate that people included in a cohort where you're studying an exposure and its relation to later outcome, you have to make sure that they didn't have the outcome when they were included. This does not at all apply to my previous examples of preterm birth. But if you're studying cancer, for example, you have to be sure that they don't have cancer when you include them in the cohort, because then they will very soon have an outcome and be recorded as, the exposure, Then you measure actually the outcome and the exposure at the same time, which is problematic. And if you're studying mortality, because that's a very commonly used outcomes in many studies, if you have some other outcome that you're interested in, let's say myocardial infarction in adults, it's always very good if you know what that person died from. If that was from a traffic accident, that's very informative, because then you're sure that he or she didn't die from myocardial infarction that you're studying. So causes of death is always better than just studying mortality in general. Yes?
We asked a little more about this demonstration of that the outcome is not present in the beginning.
Yes.
For example, if I want to follow up people with look if they have under follow up if they get hypertension. If I in the beginning exclude those with blood pressure over 130, then I kind of get a different kind of population that I'm interested in. I'm interested in the whole population, and then I cut those with high levels of blood pressure away. So isn't it manipulating my population sample?
Yes, what is your exposure?
Yes, but you're giving a star only to those who drop out the people with measured blood pressure over 130, and isn't it dependent on the question that if I ask whether all people are in risk of hypertension, or whether I ask whether those with low blood pressure are in risk?
Yes, or if you may want to do two groups actually, because if you're interested in an exposure, you might study that exposure in relation to blood pressure in non-hypertensives and in hypertensives. Because that might be completely different. Let's say exercise, for example. If you're inciting people to exercise, because that's an intervention that is extremely difficult to randomize. But if you're making some kind of exercise thing in society, and you want to see the effect in people with hypertension and without hypertension, I would suggest you analyze them separately. But that's my opinion.
Yeah, and I think that you're also in that, is it a prognostic study or a risk factor research study? Prognostic study is in sick people, what alters their outcome. And I would say that your patients with already hypertension, you're looking at what alters what modifies their prognosis. As an etiologic research, what provokes the disease of hypertension. So it's not the same point of view. So it depends really on the question you're asking for. Yeah.
Was that an answer? Yes, thank you. Yeah. Great. It's good with questions because it's not so, after lunch, it's always very, very difficult to stay awake. And I spent, I don't know how many years, 5.5 in medical school, and I spent my years in medical school sleeping through lectures because I find it horribly difficult to stay awake. So I totally understand that checklists of meta-analysis after lunch is a hard subject. So what have we talked about? We have talked about selection. Now we are going to talk about comparability. We are still on the Newcastle-Ottawa Scale for quality assessment of observational studies in epidemiology, just if we lost track where we were, because I did. And comparability of cohorts on the basis of the design or analysis. And this is about how can we do to include studies that study the same exposure, perhaps the same outcome, but in very different populations. In Sweden, I don't know, I think it's only like 8% of women that are smoking in pregnancy. I don't know what that figure is in France. It might be 25% of women smoking in pregnancy in France? Yes. So if you're going to study the relation between preterm birth and asthma, smoking might be an extremely important confounder, because a confounder affects both the exposure, preterm birth, and the outcome, asthma. At least I think so. So if you're going to do a study on the relation between preterm birth and asthma, I would suggest that you include studies that control for at least maternal, but preferably perhaps paternal and household smoking as well, as the most important factor. And then, preterm birth is related to socioeconomic status, and so is asthma as well. So if I would suggest another additional factor to control for, that would be some measure of socioeconomic status. The most readily available is often maternal education. I don't know. Which measure do you have in your countries of socioeconomic status that you find easily? Maternal education in Sweden is the easiest one. In Finland? Maternal education, is that what you use for socioeconomic status? Yeah. In France? No?
It's very difficult to have that.
Yeah. And what do you use for socioeconomic status?
Well, it's a proxy, do they have a job or not?
Yeah, okay, a job. Okay, so unemployment.
Yeah, unemployment. Yeah,
Okay.
Proxy.
It's very crude, yeah. And in Italy?
Yes.
Yeah.
We use education usually.
Of the mother?
Because of the mother or the eye test in taking consideration of the father and the mother.
Okay. Yeah. So you see, already in here, we're only a few people in here coming from different countries. You can already now see the difficulties you would have if you were going to do a meta-analysis with studies from Finland, Sweden, France, and Italy. And in Croatia, for example, I don't know, Croatia, back there? What measures do you have of socioeconomic status? Sorry? No, you don't know. No, but I know it's often very difficult to find a good measure of that. I would suggest, for example, if you're going to study health in adolescents after preterm birth, you could set up as one criterion that all studies you're going to do in including your meta-analysis, should control for maternal smoking in pregnancy. That would heavily limit the number of studies that you could include. And you might think about, is that good? Or are you losing information that way? That's the flip side of the coin. If you're too strict in your quality assessment, you may lose studies that could contribute really important information to your meta-analysis. Do you understand what I mean? And you could also have as a second criterion that the studies you include control for parental education or maternal education or whatever measure of socioeconomic status. So that was the only thing that you have to think about on the parameter comparability of the cohorts that you include in your meta-analysis. Now we are coming to the last part of the Newcastle-Ottawa Scale for quality assessment, and that's how outcome is ascertained. And preferably, outcome is assessed either as an independent blind assessment. The person who assessed the outcome didn't know that you were studying this exposure in relation to that outcome. It might also be done by record linkage, because if you record linkage, for example, maternal smoking and later asthma medication, there is no risk of a bias in the person who assessed the outcome. But self-reports, does your child have asthma, have a very high probability of bias. And if there is no description of all, that's bad, of course. We'll take another blood pressure example, because I know that both Petri and me, we are interested in blood pressure after preterm birth. So if we take an example of a good assessment of blood pressure after preterm birth, is that it's directly measured by an observer who is trained to measure blood pressure and blinded for the exposure status. That is the person born preterm or not? Was the person that I'm measuring blood pressure in born preterm or not? Which is often very difficult. I've done lots of clinical follow-up studies in preterm born subjects. And the first thing they tell the investigator when they come into the room is that, it's really interesting because I was born 20 years ago in week 25, they say. That's the first thing they say when they're coming. So it's extremely difficult to blind the investigators in preterm studies. So that was Justin. You don't have to remember that part. Then, when you have assessed your outcome, you have to think about, is the follow-up long enough for outcomes to occur? Or am I too eager to do my study? And there you have to take all your medical knowledge, because no statistician in the world will help you, or epidemiologist in that case, will help you to answer this question. You have to take your clinical knowledge as a doctor into this question. What kind of disease am I studying? I recently published a paper in a very high-ranked ophthalmology journal, Ophthalmology, on retinal detachment after preterm birth. I don't know if I'm proud of that paper or not. We could show that there was an extremely high risk of retinal detachment after preterm birth in adults. But we were studying an age span where retinal detachment really doesn't occur. And we don't know if that increase in risk will persist. If we had been able to choose an age where people actually have retinal detachments, let's say 55, instead of 20 to 36, that was the age span we studied it in, we're not sure that we would have the same results. So you really have to think about the follow-up period in your cohort study. Yes, a question?
The statistician that was joining our case said that in the long run, we will all be dead.
Yes.
So that if the follow-up is too long, you also end up shrinking the differences, so that...
Yeah, exactly. Then you have the And you have the survival of the fittest problem that come into account. So really, thanks a lot for that comment. So you should really choose the relevant study period. And they are talking a little bit about it in the article that you are reading later on. And then you have to think about what is an acceptable loss of follow-up. And I have lectured actually in my clinic using almost those slides a few weeks ago. And then everyone looked at me and they were smiling and they said, okay, so what do you say? What's the acceptable percentage? Because they really wanted to know. And I felt that I didn't really have an answer to that, and I couldn't really find one in the literature. I don't know, what do you say? It depends on the type of study, on the type of exposure, on the type of outcome. But the problem is that, I mean, you don't know, if people are really lost to follow up, you don't know anything about those who were lost. Did they all have the outcome? Or didn't they have the outcome at all? And if you do some simple maths, you will realize that already at 25% that are completely lost to follow up, and you don't know anything about them. That will largely affect the results of your study, if you're unlucky. And you were who talked about, no one is talking about imputation? Yes?
No, it's not.
No one is talking about imputation today. That's a pity, because that's an emerging, I would say, a way to partly solve that problem. Not completely, but if you have some basic variables, you can invent other variables based on that distribution of the knowledge you have of that person. You can kind of guess what happened to those who were lost to follow up, and that's imputation, very basically. So there you should contact your statistician, because I said earlier that your statistician couldn't help you with the follow-up period, but your statistician can clearly help you with your multiple imputation if you have subjects that are lost to follow-up. Yes?
Hello. Okay. Talking about the imputation you're using the variables you have measured in baseline, and you're putting in the variables you are missing, and that's a good thing, and enable us to include those people that would otherwise miss from the analysis. But isn't there a problem with the major problem with dropouts is, I think, that if the relationship in the dropouts would be different as it is in your remaining study cohort, in that case you get the wrong answer. And once you impute, in this case, the missing variables, don't you miss this horrible thing of then you kind of interpreted the association is the same in those who didn't participate as comparison to those who participated.
You're totally right, then you're re-amending your thing. But you can, and you shouldn't, of course, if you're doing that, you shouldn't include that into your estimate, of course. But it could perhaps, I don't know what you say, it could perhaps give an idea of what the effect might have been in those who were lost to follow up. But actually, you're totally right, it's doing the same thing twice.
Yes.
Yeah. So you have a point. What I'm usually doing is, as you said, we are using imputation for the exposure, and we are not really confident yet with using that in our main analysis. I don't know what you do. Do you include the imputations in your main analysis, or only in sensitivity analysis? Sensitivity, yeah. But our experience is that reviewers of the big papers, the high-impact papers, they often ask for imputations for missing data nowadays.
This in JAMA Pediatrics some months ago,
Okay.
imputation.
Yeah.
So that is not very technical, not too technical, we can read it. And
Interesting,
it's
I should
Cummings.
read it, I feel, yeah.
Author is Cummings.
Yeah.
Cummings.
Camirsi.
Cumming, the author.
Yeah.
No, Cumming. C-U-M-M-I.
C-U-M-M-I, Irsi, yes. Great. So this was just about loss to follow up. We don't really know what happened. We will probably not be able to compute it. And you have to think about, is it important for your relation between exposure and outcome or not? And that was the last slide on Newcastle-Ottawa Scale. So, in summary of that scale, it's used to assess the study quality of studies included in meta-analysis, and you assess the selection, the comparability, and the outcome assessment of the cohort studies that you include in your meta-analysis. Yes.
No, okay, now it works. I think I've heard quite a lot of critique on using quality scales for assessing quality in these observational studies. Have you tried using other approaches? Or?
Other quality scales?
No, another approach like making not a scale, but like making something more specific for what you're looking at. Because I think sometimes it doesn't really fit very well to the observational setup. No, I'm sitting in the problem right now. So.
I have the same question because we used this scale recently for a meta-analysis on unselected birth cohort studies on the relationship between prenatal and postnatal exposure to maternal smoking and wheezing and asthma. So. The question is that.
But you were not on the paper that we are looking at later, pediatrics.
Please.
Pediatrics, you're going to read it on.
No. It's another. Yeah, I know that the paper, but we did another meta-analysis with partially different results. So, and is submitted is almost accepted. Hope so. No, but the problem is that we found difficult to use this scale, in particular for outcome, because outcome in this kind of studies is almost always studied by questionnaires. Wheezing or asthma, especially wheezing, and you don't have any other way. Yeah, always, almost always in all the studies, and also for the problem of loss to follow up, because if you study big or also big cohort, important birth cohort studies, the prevalence of people lost to follow-up is quite high, and if you look at wheezing in the first 2 to 3 years of life, not, but if you look at asthma at school age, is high. So I found it difficult to give a number in the end.
Did you find it better, or do you have any suggestions of better scales for assessments?
No, but the problem you get with the questionnaires, I suppose your questionnaires have been validated before as to be correlated to real clinic asthma or not?
I mean, questionnaire on asthma nowadays are almost all the same. Are ISAC questionnaire or ISAC adapted questionnaires.
And so, well, overall, you don't have better anyway. So all your studies, if you have several studies that find the same results, even if outcome is a bit lousy, nevertheless, you always find an association. I don't know what are the results, but so, yeah.
It was not so easy.
No.
But I have a suggestion. What you can do when you have, when you give your stars to your different studies that you're going to include in your meta-analysis, you can always do subgroup analysis afterwards to see if you have the same effect in the studies with few stars as in the studies that have many stars. So that's one way. Oh, you have talked about it.
The Cochrane collaboration
Yeah.
suggests.
Yeah.
We did
Yeah.
study and let's say 5 variable scores.
Yeah. Yeah, and that's problematic. And you'll see that they study what you're going to read later on, they have 5 to 7 stars, so no 9 stars studies, for example.
But I think that some of the people behind the Cochrane they are some of the people that says that it's not a good idea to do this. And I think they have suggested to do something more similar to their own assessment of bias, but it's very difficult to apply to observational studies. So I don't know.
That's the problem, because I really thought about what can we use from the Cochrane collaboration studies when we're talking about observational studies, but I couldn't really integrate that into something that I felt that I could teach you at least. But I can keep looking and come back next year if I found something. Because I mean, I totally understand that this is very schematic, which is often a problem in research when you try to apply a scheme that is too tight. So when you are reporting the methods, you have to assess the study quality, and that's what we just did. You have to assess the heterogeneity. We're going to talk a little bit about it, not much, but a little bit. And you have to provide a complete description of your statistical methods so that people are going to be able to replicate your findings. And you need appropriate tables and graphs, and that's nothing extraordinary. That's like it usually is in research. When you're going to assess heterogeneity, you look at, are the results from the different studies included in my meta-analysis consistent? And if you see clearly that the confidence intervals overlap poorly, you probably will have heterogeneity in your meta-analysis. And there are tests, as you know, probably know, you talked about them perhaps this morning, for heterogeneity. But if you have a non-significant statistical test for heterogeneity, it doesn't mean that there is no heterogeneity. It might just be that you have a power problem. So you have heterogeneity. Would you have twice as many studies? You would be able to show that there was significant heterogeneity. So, and I think that I really don't like the statistical approach to heterogeneity so much, but I like the epidemiological approach to heterogeneity, because when you see the confidence intervals of the studies, different effects and how they overlap and don't overlap, it makes me think at least of why. So my suggestion is that when you see heterogeneity, you should examine your studies closely and try to understand why you see this variation in effect between studies. And it might actually be that you have different study populations, for example, or different exposures, different outcomes. And if you have much heterogeneity in a study, it might be inappropriate to summarize your included studies into a single summary measure. And I guess you perhaps said that also this morning. That, I mean, if you have some studies showing that something is protective and other studies showing that it's a strong risk factor, you might get a summary effect that it's, a null finding, although you might miss really important information in the different studies. So what you could think about instead is subgroup analysis, and also do sensitivity analysis, excluding certain studies showing different results to see what you find. But this is just a very brief overview of heterogeneity. I don't know, did you talk about fixed and random effects model?
Just the name.
Just the name.
Did you not explain what
No. Because you have two components of variability in studies. You have the inherent differences of the effect that you can have in the studies because of different design, different populations, different treatments, different adjustments, etc. And that is what will create your variability that is between the studies. They are slightly different, so you'll have variability. But then you also have the variability that you always have within a study. And that's due to sampling error, or, there is always a biological variability. It's not always sampling error, but that's within the study. So what you use when you have this variability is that the random effects model assume that there are real differences between all the studies in the magnitude of the effect in the random effects model. And I think that makes sense. I wouldn't expect, I don't know, whatever exposure in France, which is a country that is much warmer and people eat better and they smoke more, to have the same effects as in a study in Sweden. Although you do everything that is possible to make your studies comparable, there will always be between study variability. What I suggested is, what is recommended is that the random effects model is always used in observational studies when you do meta-analysis, because you cannot really assume that there will be a fixed effect. There will always be variability that is quite important between studies. And this is a bit abstract to me, and I'm not at all going into the statistics of this, because that makes it more mathematical and difficult, I think. But the question is, will the treat exposure produce more benefit or harm on average? And that's what you get when you do your summary effect. And then we have another thing, and I'm only going through this also really briefly, because otherwise you'll get totally stuck in your articles. Because the I-square that you'll see in all meta-analysis describes the percentage of total variation across studies that is due to the heterogeneity rather than chance. And when this is computed according to a formula that is not too complicated, you'll have a value that you make to a percent value. So the I-square always is between 0 and 100%. And if you have negative values of I-square when you compute them, you put them to 0. So you can see that you have I-square values that are 0 in some articles. And if you have an I-square value of 0, you indicate that you have no observed heterogeneity. And if you have larger values, that's your amount of heterogeneity in that meta-analysis. And this is, you'll have one example of it, I think, later on. If you only have one study, you will of course have an I-square value that is 0, because you can't have any heterogeneity between studies if you have only one in your subgroup analysis. So, that was heterogeneity. Now we are continuing with the reporting of the results. And in all meta-analysis, there should be a graphic summarizing the individual study estimates and the overall estimates if you decide to make one. And that is often presented as the forest plot. And this is just an example of forest plot that I found, where you have, I mean, you went through this morning? You went through forest plots, yeah. Do you feel that you need more information on what a forest plot is? No, we'll skip that. Thanks. Fantastic. Yeah, another part with forest plots, yeah. We'll skip that one as well, because, I mean, you can read it, but it's just that is a forest plot. Thank you. And when you're going to report your discussion of your meta-analysis, you need to quantitatively assess your bias. For example, your publication bias that might be really important in some studies. Because if all the studies showing something else are not published, then your results from your meta-analysis might be completely opposite the truth. And I guess you talked about funnel plots also this morning? Yes. Because one way to assess publication bias is funnel plots. And so that's nothing new to you. So now you have discussed your bias. Then you have to justify why you excluded so many articles and how that may have affected your results. And you also have to discuss how high was the quality of the studies included. And if you really felt that you had a problem with the Newcastle-Ottawa Scale, it didn't fit your kind of studies, then this is the part of your article where you're able to discuss your problems or how you dealt with it and why and how it changed things. I would say we started out talking on fruit salads. And I would say that the weaknesses of a fruit salad are also the strengths, because in meta-analysis you really have the possibility to, within the same study different populations, different protocols, different study designs, and compare the effects. from those things. So you can find new knowledge. By doing a meta-analysis, you might discover when you look at the heterogeneity that this exposure is only related to outcome in women, let's say, and not in men. And that may actually be new knowledge that you would never find without doing this. And it has also been assessed if there, when you're looking at adverse effects, because I know that there are 2 pharmacologists here, right? Pharmacologists? Yeah. And I don't know if you're familiar with this publication, but I looked, has there been assessments of the differences between meta-analysis of observational studies and meta-analysis of RCTs? And there was one published in PLOS Medicine 2 years ago where they couldn't really find any difference in effect between observational studies and meta-analysis of the same drug with the same outcomes, which I found interesting. Yes. Would you like some journal club now? We are going, actually I picked a paper, you might find that, I mean you're really familiar with it, I didn't know that, but you are. You might find that it's slightly boring, but that was actually the purpose of this paper. Because you proposed one that I found really interesting on circumcision and UTI in boys. But I didn't want the question to be so interesting, the research question, because I wanted it to be something that you accept without discussion. So you really could look at how did they do their meta-analysis, do they fulfill the checklist criteria, how did they quality assess it, and so on. So I suggest that you read the article by yourself in a systematic way, in small groups, that you use the MOOS checklist and the NOS, Newcastle-Ottawa checklists that I provided back there, and yet that you discuss this meta-analysis in small groups. And then I would be really happy to, when we're finished with all that, to hear your opinion, and if you could say something about your findings. I think that would really add some knowledge in the overall discussion afterwards. I think that unfortunately there is no coffee yet. No. So you'll have to discuss without coffee, but I can keep an eye as soon as the coffee appears. I can tell you, right? How much time do you need? Half an hour, a bit more? Yeah. I have all the supplemental material on a USB key that has been virus scanned today. So if you would like, I don't know, do you have computers? You can get all the supplemental tables as well.